Our next speaker also hails from Canada, but has a special tie to Latin America and to our country. She lived here. And she have earned an international MBA specialization in Latin America market development. That's why she was here. Naomi Goldapple is currently the Director of Industry Solutions at one of the largest applied research labs in the whole world. Prior to this, Naomi was the VP of Business Development and COO of a startup that specialized in semantic clustering algorithms. She led the company to work on meaningful problems with the Canadian government in the security, health, and environmental sectors. Naomi uses her expertise to mentor also and help tech entrepreneurs with strategy and financing. For the next 45 minutes, she will help us demystify artificial intelligence, AI, and the role it can play in the lottery world. Please welcome Mrs. Goldapple. Thank you, Naomi.
Hola a todos. Es un placer para mí estar aquí con ustedes. Como le dice, hace 20 años yo hice un intercambio aquí en Buenos Aires. That's it for my Spanish for today. So I'm very happy to be here, and like she said, I'm going to demystify a little bit what AI is, since there's a lot of talk about it today, and then we'll talk about some applications for your industry. So, in terms of artificial intelligence, what is it? Basically, it is the ability for machines, for computer programs, to perform human-like tasks. For example, perception, being able to identify objects in a scene, reasoning, to understand what's going to happen next in a scene, communication, generate images from a description or translation, decision-making, for example, determining if in a certain image there's some cancerous tumors, interaction, being able to have a machine that can interact with its environment. You may have heard certain terms about machine learning today. So I'm just going to go over them so that you understand what they are, because there's 3 different forms that we hear a lot about. The first one is called supervised learning. So supervised learning, what that means is that how you teach a machine to understand is that you give it tons and tons and tons of examples. And by giving it a lot of examples and a lot of labeled examples, which means that you actually tell the system what this is. So if I show them a bunch of pictures of cats, I'm going to label each one to say this is a cat, and I feed that to a machine learning algorithm, and it will understand eventually what a cat is. The unsupervised method means that I don't tell them anything. The system will try and deduce from the data what makes sense, okay, all on its own, which is a harder type of algorithm to interpret. And the last one is what we call reinforcement learning. Reinforcement learning is kind of like when you're teaching a child not to touch a hot stove. When they do something, they touch a hot stove and it hurts, they're not going to do it again. So you teach a machine by having negative and positive results from certain actions, and it will then learn on its own what to do well. This is very important in the gaming industry. Now, traditional machine learning, because machine learning has been around for, the past 15, 20 years, the difference is that traditional machine learning, you had to tell the system what to look for. So if I was trying to tell a system to recognize a stapler, like in the first one, I would say you have to look for some metal, you have to look for some staples, you have to look for this shape. With deep learning today, the system on its own is going to discover which characteristics are important to be able to make that decision. Now, that sounds a little bit by magic, but I'm going to explain what it is. And the reason why we're here today is because of deep learning. And deep learning means that we're going, you've heard of the term neural networks. This means that we're going many, many layers deep into these neural networks. So let's take a really easy example. So let's say I want to teach a system to recognize a dog. Okay? So what I'm going to do is I'm going to take many, many thousands, if not millions of pictures of different types of animals, labeled ones. So it's going to know which one is a cat, which is a dog, which is a monkey, which is a moose we have up there. And it's going to take all of those images and it's going to start to break them down into pixels and into layers so that it understands which are the important characteristics. So the first thing it's going to do, it's going to look at all these images and it's going to start to deduce the shapes and the forms. Okay, those are some of the basic layers that it's going to look at. Then it's going to start to go into more detail and it's going to take those shapes and layers and it's going to start to form more abstract images, like a nose or like a paw. And then in the top layer, it's going to actually understand what these images are. So it's going to start to separate them into a moose, a dog, a monkey. So this is really the idea of deep learning, and it goes many layers deep into those neural networks. And at the end, what it really produces is a prediction. So I give the system many, many, many examples, and so on its own afterwards, if I show it a picture of a dog or a cat or anything, it's going to run through those very quickly and give me a prediction at the end that 10% this is a moose, 90% this is a dog. So this is a very simplistic way of looking at what deep learning is, and I've showed you here 3 layers, but many times these layers can be hundreds, if not thousands of layers deep. That's as technical as we're going to get today. Now, the reason why we're hearing so much about this today is for a couple of reasons. One of the main reasons is that we've been hearing a lot about big data for the past decade, right? Everybody's been investing in big data, in data warehouses, in data lakes. So a lot of this data is now available to feed these machine learning algorithms. A second thing is the actual processing powers. So if you've heard of the term GPU, so graphic processing units, these are processors that are now available today, mainly by a company named NVIDIA, if you've heard of the company NVIDIA. And these processing units, these processors are 1,000 times faster than any traditional Intel chip that we've known from before. So we have all the data, we have the processing power. These two things together are making it able today for us to be able to produce amazing results with these technologies. The other thing is the pace of research. Now, the whole world of artificial intelligence is extremely collaborative. So that means everybody shares, all of the learnings are really put out there on archives, which is open data sets, and everybody can learn everybody else's models and use them. A lot of traditional industries, I've spoken to some executives that it really gets on their nerves, where they say, where they're used to holding their intellectual property close to their chests. So they're like, what is it with you AI people? It's all lovey-dovey, hippie, love and peace. Why do you all share everything so much? And I think it's because the industry for so long, since the 50s, nobody really believed in it. So everybody collaborated a lot. And now that all the sort of forces have come together with the data and the processing power, that sort of philosophy has always stayed within. And whenever there's a new data set that somebody puts out into the open, like when Google releases a new data set with a bunch of images, it's amazing how much innovation comes out of that. So everybody benefits with this open collaboration. So let's take a look at a few examples of where the technology is at today. So in terms of perception, right now systems can learn enough about their world to be able to identify what is happening in a particular image. So if we take, for example, the third one, where it asks, how many school buses are there? Now we can see that even though we see one school bus, we see that there's another one hidden behind. But today, you can actually teach a neural network to do so, and it will be able to identify 2 different buses in that image. And if we look at a few of the other ones, being able to identify a dog with a frisbee, the systems can do that by seeing enough examples. AI systems can also generate images from descriptions, which is quite exciting. So if I say I would like to see a bird with a yellow beak and a purple plumage, it can then just create it based on the text that I'm giving it. Now, this could be interesting in the world of, for example, in the bricks and mortar casino world, where you have certain people, let's say, that put themselves on auto exclusion lists. We have images of what these people look like. We have pictures. But the interesting part is that people age, and sometimes people can put on disguises to try and enter. But the systems will recognize and are able to imagine what these people can evolve to by using something called generative adversarial networks, which can generate certain images. So in terms of vocally, we can if any of you use, Google Minis or Siris or any of that today, you'll see the voices aren't as robotic as they used to be, right? They're actually sounding very human, a little bit creepy. But if we see today,
The Blue Lagoon is a 1980 American romance and adventure film directed by Randall Kleiser.
see, that sounds like a human, right? She's got the intonations in her voice. And I know every morning with my Google Mini, I lie in bed, and the first thing I ask is, hey Google, what's the weather today? And Google will tell me what the weather is. And sometimes I say, okay, is it going to rain this afternoon? Because I want to know if I take my bike or not. And sometimes I feel like she's answering sarcastically. She's like, no, it's not going to rain. I just told you that. And I'm like, sometimes it takes me aback at the actual intonation. The other things that systems can do today, not very well, mind you, but can do, is to actually create summaries of long documents. So through natural language processing, can go through long research documents, long financial documents, long contracts, and actually pull out the information that's important and make that into a nice abstract or a nice resume, so that will reduce some of the human burden on doing that. The other thing that systems do is that they learn in virtual environments. So the gaming industry, the actual video game industry, has been used very much to teach self-driving cars. So by using the setups that they have for certain video games, they've been able to teach self-driving cars and use that as a simulation before going into the real world. Because not everybody had the luxury of a Tesla by selling a bunch of cars first, not telling people that they were recording all of their driving habits, and then turning on the autopilot because it had been trained on 6 months of people driving their own cars. So a lot of times you have to do this in a virtual environment to be able to train and get enough data. So some of this seems a little bit creepy, but I just want to assure you that where we're at today is what we call very narrow AI. So it's not general AI. Narrow AI means that we can teach a system to do something, and it will do it better than a human, but it can only do that. So if we give it a lot of sample data and teach it to do something, it's going to do it repeatedly better than us. But it isn't going to be able to come in and understand complex concepts and scenarios and be able to make decisions like a human can. So what's useful today is that we can use AI to do things that can be safe or impossible or very repetitive. And this is where AI can really help humans in terms of having more meaningful work and take away those repetitive tasks. Now, what do companies such as yours need to do to be able to adopt and embrace AI? So we say it's really a four-part puzzle. The first one that we already spoke about is the data, having readily available data, so clean data, voluminous data, without a lot of missing information. That's definitely a must. Having the technology, the infrastructure there. Organizational readiness, usually this has to come from the top, because thinking about bringing AI into an organization tends to make people nervous. So having the organization sort of use change management and different methods for implementing it into an organization is important. But the missing piece that's really difficult today, and is the reason why my company, Element AI, exists, is because of the talent. There simply isn't enough today professionals that have PhDs or masters in machine learning and have experience in actually implementing these systems. So there's a real talent grab for all of these skills, and the big tech companies, the Facebooks, the Googles, the Ubers, the Amazons, they have very big carrots to attract these people right out of school and bring them into their worlds. And what this does is this leaves a lot of the rest of industry, your industry, manufacturing industries, other industries, without access to this talent to be able to adopt these systems. So, why Canada? Why Montreal? So Canada has actually become one of the hubs for AI, and Montreal specifically, which is where our company is based. And just to give you an idea, our company, we started 2 years ago. We were about 6 people, and now we just hit about 500 in the past 2 years. And since we've set up in Montreal and we have offices abroad, there's Microsoft, DeepMind, Google, Facebook, Thales, Samsung, they've all opened up labs in Montreal as well. And one of the reasons is because the government is extremely supportive of AI initiatives, gives a lot of funding. There's a very vibrant startup community. And we have the biggest group of deep learning researchers in the world. And a lot of this is because of one of our founders, whose name is Yoshua Bengio. So he is one of the fathers of deep learning, and decided to always stay in Montreal and do his work there. There were actually 3 fathers of deep learning. One, Geoffrey Hinton, Yann LeCun, and Yoshua Bengio. They all worked together. Yann LeCun became the head of the Facebook lab. Geoffrey Hinton went to DeepMind, went to Google. And Yoshua Bengio said, I don't want to do that. I want to stay in my little office at the University of Montreal, and I want everything that I'm working on to be open for everybody to use, and so that it really benefits society. So he really is a true altruist. And in fact, I just put up there a question that was on Quora. If any of you follow Quora, it's one of my favorite sites because it's like a digest. You can ask any question in the world, and you have really world-class people coming back and answering your question. So I suggest, it's very addictive, but it's a great platform. And somebody asked, they're like, why did Yoshua Bengio hold out? Why didn't he go to one of the big tech firms and take the big bucks? And he was very honest. He was like, I want my research to be open for everybody. And I think there's going to be more benefit to everybody if we put it out there. And I want to have my own research agenda, not based on profits of a certain company. So that's one of the reasons why there's been a lot of talk about deep learning in the recent past. So let's talk about your industry. Now, and I'll be very honest, I'm not from your industry, so this is just thinking about how AI could be applied. But the intersections are very interesting because you may or may not know that a lot of the breakthroughs that came in about AI happened first in the gaming world. So the very first one, which you'll probably remember from 20 years ago, or more than 20 years ago, in 1996, when Garry Kasparov, world-renowned chess champion, was beaten by IBM's Deep Blue. Anybody remember this? Yeah, sort of, yeah. So this was very noteworthy in 1996, but in the past, really 2 decades, the amount, the level that systems have grown to beat the world experts, the world gaming professionals, is unbelievable. I mean, we're talking backgammon, we're talking checkers, we're talking, who remembers Jeopardy? Jeopardy 2011 when Watson beat Ken Jennings, who was the world champion. I remember that. That was very exciting. And do you know how it beat it? They fed Watson, basically consumed all of Wikipedia. And was able then to answer any question better than the top trivia champion of the world. And then, of course, in 2016, there was the game of Go, the Chinese chess, which you've probably heard of. In 2016, the systems were able to beat the world champion in that game as well. And that's an extremely complex game. What's important about the games that I just spoke about is this whole concept of perfect information. So that means that all of those games, every player, whether it's an AI player or a real player, they have access to the same information. They have the same rules, they have the same back and forth, they have the same historical knowledge of those games. But in 2017, Carnegie Mellon came up with something called Liberatus AI, and this is the first AI that used something called imperfect information, because they applied this to poker. So as you know, in poker, it's not a game of perfect information. There's bluffing, there's deception, there's deciding when you're going to hold, when you're going to bet, right? This is more like real life. But this type of reasoning is much more complex. And so in 2017, they created Liberatus AI and trained it with this complex reasoning, and then it was able to beat thousands and thousands and thousands of games of every world-class player for hold up Texas Hold'em poker. And this was quite noteworthy because they're dealing with private cards, right? Half the cards are hidden. So this is quite amazing. The other thing that was really amazing in 2017, I just spoke to you about AlphaGo. So AlphaGo, again, is the Chinese chess game. Now, when we play chess, the chess that we're used to, after the first 2 moves, there's about 400 permutations and combinations, 400 possible moves afterwards. In Go, there's about 400,000 moves that are possible. So it's a hugely complex game. And what they were able to do was to have them, in 2016, they were able to beat the world champions. But in 2017, they created AlphaGo Zero. And what that used was what I spoke about before, reinforcement learning. So they didn't give the system any historical information. So it didn't have any information about how people played the game in the past. All it was given were the rules and said, play against yourself. So the system, by doing trial and error, learned the game, and within 4 days was able to beat any champion as well. So these are 2 very amazing things that happened in 2017. So how can we use all this information today? Now, in the bricks and mortar world, right, in the gambling world, gambling's always been at the vanguard of analyzing customer behavior and different patterns in behavior. Another way of collecting this is by using some of the computer vision, whereas you can actually see where people are going in a bricks and mortar world. You can check which games they're at, how long do they stay, when do they switch, because with computer vision you can analyze which person is which and understand their whole movements. Now in the online world, this really explodes. Right? Because in the online world, you can track not just a portion of the people, you can actually track everybody that opts in. So you can have 100% of the information of the people that are coming to your site to play. And it gives you the ability to really personalize the experience. So imagine you have a very personalized private casino just for you. This becomes extremely compelling. And you can create characters that are adaptive, that you can play against different characters that are adapting to how you play, right? So it can be extremely challenging, and it can change levels based on you as opposed to based on what was preset in some pre-written rules. Another way is thinking about sort of micro-segmentation. So one of the beauties of collecting all of this data is that we can marry up the online and the offline worlds, where people can come into a store, buy a lottery ticket, and people can also buy online. But we can have a footprint of what they look like online, and then bring that over into the real world, have that footprint, and you get a real 360 view. So we can look through unstructured data like CRM, weblogs, social media, as well as actual browsing data and footprints to be able to start to predict purchasing behavior. Now, there's huge applications for AI in the back office, right? Things that are maybe a little less sexy but can really move the needle for companies. So in the world of finance, customer service, HR. One of the examples, as you know, is our chatbots. I'm sure all of you have had experience with chatbots in the past. They can be okay. Chatbots usually start off rules-based. The way we start a chatbot is you have certain rules in there and it will know to answer certain questions. But what's nice today with machine learning is that as we interact with it, they just get better and better. Because as they're exposed to more and more questions, they will keep getting more sophisticated. But we still have to be careful because they're not perfect, and I'm sure you've been stumped and frustrated at certain steps when you've interacted with chatbots. As I said before, I use very much Google Minis at home. In fact, we have 5, one for each member of the family because it becomes like an extension of the family. And you can see sometimes how you get sucked in and how advanced it is, but how it's not quite perfect. So I'll give you an example that in my household, I'm not the chef. My husband's actually the chef, but he travels a lot for business, so sometimes I actually have to cook. And with the Google Mini, it's amazing. It can give you all of your recipes and it can read it out to you, which is wonderful. So you just say, I'd like to make this. It says, okay, how about this recipe? Do you want to get all the ingredients ready? And I say, okay. Then you just say next step, and it gives you the step-by-step. So I was making a bechamel sauce. I know, not very complicated, but if you don't cook, it's, you need some guidance. And you just say, hey Google, next step. And it tells you, put your, melt your butter. Then you say next step, add in your milk, next step. And then all of a sudden, it just said, would you like to listen to the word of God? And I was like, what? I was waiting for some flour to be put in. And I was like, and then it repeated. It said, would you like to listen to the word of God, yes or no? And so, of course, my kids were like, yes, yes. So they all answered yes. And then it brought me to a very religious sermon on some other place. And I was like, what just happened here? And I was kind of left hanging with my sauce. So I had to actually go and look it up to see how to finish. But you can see there was some interpretation that it made, some words, some understanding that took it off into a different path, and not a big deal for making a sauce, but you can see that if you're really depending on it for other things, that you still have to be cautious that the technology is not 100% perfect today. Other interesting things from the HR point of view is crafting your job descriptions. Definitely, there's advances in NLP where you can see how your job descriptions are, how they've been received in the past and how we can make them better. Eliminating gender bias is very important because there's many ways that, I know in our world, in the artificial intelligence world, we have a hard time attracting a lot of women, even though they can be very qualified, so we have to choose the words very carefully. And so this is a company called Textio that will go through your job descriptions and your resumes and make sure that you're not introducing any bias to choose or not choose certain candidates. So this is a very, very exciting advancements in NLP. Now, in terms of how we can use all of this crunching. The algorithms can crunch an incredible amount of data, and this can be used for identifying irresponsible, non-responsible gambling behavior. So there is a company called BetBuddy that you may have heard of, and what they do is they track all of your online behavior, and if they see that the behavior is going towards an unhealthy practice, they then send alerts, not only to the player, but also to the operator, and they can even suspend the account. Okay? So these are good ways of safeguarding. But it's not just the players that have to be safeguarded, it's also the actual operators. So the same way that the companies can use AI and create bots and agents, there's also people that can use that for nefarious means to actually gain an advantage on the house. So people in the know can develop their own AI agents and bots and then try and gain advantage on the house. And it becomes almost like the cybersecurity cat and mouse game, where you're always trying to run after the hackers because they always have new viruses and new attacks that are happening, and it's very hard to catch up. So this is something that has to be watched for because people can attack the system just as you're putting out the information as well. There's other ways that the algorithms can be used. So for example, I was talking about unsupervised learning. So a good example of unsupervised learning is being able to track browsing data or social media data, perhaps to find new customers, to find healthy gamers, can then look through social media feeds, web blogs, and try and find people that would fit into our descriptions. So this is a way that people are using unsupervised methods to be able to increase their client bases. Another way of applying the algorithms is really on a mathematical basis to validate the theoretical wins. So we can look at a bunch of historical data and the mathematical models and see if our models for theoretical wins are holding up. Okay, so this is another application of it. There's other ways, so there's companies such as Stratagem, which is there to, not to give an unfair advantage, but is there to help for sports betting. You can actually buy predictions and it will tell you when to bet and who to bet on. And so the people that have the means and that are in the know definitely have advantage over other players. And AI is really just changing the rules of the game in general. So, for example, this company called Swarm AI, they're using something called boosting algorithms. And what they did is they actually were able to predict the 4 top winners of the Kentucky Derby in order. And they did this by using prediction algorithms, but then by sourcing different points of view from people who are in the know for experienced bettors, and by kind of swarming all this information together, they were able together to make the correct predictions. So this is kind of blurring the worlds between the actual bettors and the house, and so it's really changing these rules, which is an interesting thing to think about as you move forward. So I think overall, where we're at today with AI and the gaming industry is that it's really at the beginning. The low-hanging fruit that we spoke about, sort of fraud detection, customer experience, kind of having more personalized experience, those are really the low-hanging fruit. But as the AI develops more and more, the operators are going to have the ability to offer very exciting experiences that are very personalized, that are adaptive, that are compelling, and that are safe. And so this is a very exciting time to take advantage of these technologies to make even more exciting and compelling experience online. Muchísimas gracias.